Big fan of your work, by the way. Love GA Query. You guys should bring it back. Sorry.
Don't bring up
All right, is it on? We're good? All right, so I'm here to talk about JavaScript debugging. So when I sat down to prepare for this talk, I thought it'd be really interesting to start with the question, how far have we come in terms of JavaScript debugging, JavaScript development tools? And then I tried to remember the first line of JavaScript code that I've ever written. And that brought me back to 2001. In 2001, I was in high school, and I did Visual Basic programming on the side. I really enjoyed interactive programming. I used to hack together as little code as possible to implement something meaningful and instantly jump into debugging. For the old school VB programmers out there, you may remember the immediate. I relied really heavily on this window. It's basically a REPL or a console. You can change variables, you can even call procedures. I used to explore different ways of doing things without having to stop the program and going back to code. And that really shortened the delay between the development loop. So I spent a lot of my time inside the immediate window. And then the web started becoming ubiquitous. I should say I'm from Jordan, and the whole country was really late to the web and the internet. So 2001 was where we started to see explosive growth in the web. After seeing that everyone had a browser, my grandmother had one, my friends had one, it really inspired me to try to figure out how to program the browser. When programming VB, one of the hardest parts is going out there and installing the program. So I learned a little bit of HTML and then opened my first script tag. I think I wrote something like document.write hello world, and then opened the browser. And I saw this. I was really surprised. It just ignored me. It did nothing. It was just a blank page. It didn't give me an error message. It didn't give me anything. And I thought I seriously did something wrong. I went back to the code, looked at it, and then went back to the browser and saw nothing. Finally, I noticed something yellow in the right bottom corner. You may see it. But then I saw this. This little guy was just chilling there. I thought it might trying to tell me something. So I clicked it. And sure enough, it was trying to tell me that there was an error on the page. And it gave me this cryptic message, object expected. After seeing this and struggling for a few more days trying to make something with the web, I remember closing off the browser and swearing off JavaScript. And I said, like, this platform is doomed. Nobody would probably program in JavaScript anymore. And I was really, really annoyed by it. I find it a little bit amusing that I'm here today to talk about JavaScript debugging, and that was my first interaction with it. But the point I'm trying to make is we've come a long way, from the silly yellow triangle to the state-of-the-art dev tools that we have today. So a little bit about me. I worked at Facebook. Before that, I worked at Codecademy. On the side, I like to play with JavaScript. I write a lot of useless JavaScript, but sometimes I luck out and have something useful. In the past, I worked on a project called Replit, which was the first production mscripting app. We compiled a bunch of interpreters to JavaScript. More recently, I worked on something called Debug.js, which tries to implement a debugger inside the browser. You can learn more at my blog, or on the internet. My handle is Masad. So I'm going to talk about three things today. Basically, code that's easier to debug, debugging tips and tricks, and then the tools available. So code that's easier to debug. Using functions and closures as the basic unit of abstraction is a lot of fun and can be really productive. But at times, I want to make the point that it could be hard to debug. So this warning is for the faint-hearted out there. I'm going to be throwing around a few contrived examples. I didn't have a lot of time to polish out the examples, but they should get the point across. So let's say you want to implement a counter module that can simply be incremented. You may do it. Let me just look if, all right. I'm going to use my super weapon that Alex showed me. All right. Good enough. So if you want to implement the counter module using the closure pattern, you would do something like a function called counter that takes in a value and returns a function. When called, will increment the value and return the value. If you want to do it using classes, you'd have, this is ES6 classes, by the way, because fuck it. And so if you would have a constructor, and that constructor would set a value, and then you have a method called increment that would increment the value and then return it. Using classes, you can look up counter.value from the outside. Closures really hide their variables really well, which is valuable for production apps, but for production, it's going to be hard to get at the insides of the module and be able to watch it and see it change over time and test it out. And you can't even change it. Sometimes in debugging, you want to change values just to get a feel of what would happen with your application, just to test it out. You can't monkey patch closures. One of the values of using dynamic languages is how fast we can try out new ideas. Having a language as malleable as JS, we can do things like redefining a method at runtime, just to try out a new idea. Of course, it's going to be stupid to sort of redefine increment to decrement, but sometimes, what the heck, you want to try something new without going back to the editor and having a long cycle. If you want to implement the debug example by using pure functions, you may do something like having a counter function that takes a value that returns a function. When called, will return the original value, and then you will have an increment function that takes the function returned from the original function, and when called, will call the original function and adds one to it. So basically just doing the counter using lambda calculus. Now, the problem with that is you can't really point anywhere and say, this is where the state changed. Because guess what? There's no state. The state never changed. This could be really productive at times, but I would argue that tools today we have are not really well suited to this type of coding, although it's pretty fun. So at least in development, so another tip, at least in development, I'd argue that it's also really valuable to put at least your top-level classes and objects on the global namespace, just to have them accessible from the console. Why? Because after the program has finished executing and it's in the idle state, you shouldn't have to make it run again just to set a breakpoint, in order to query the state of the application. Or, for example, you clicked something, something happened, you want to know if the right thing happened, the state has been updated, you want to be able to do that from the console. You want to also be able to jumpstart code paths from the console. So for example, if you have a user model that re-renders the user profile, and you want to debug that process, you want to debug it over and over again, you want to be able to just jumpstart that process just from the console. So just putting your top-level objects in the global namespace could be really valuable in debugging. So another really valuable point is you can quickly set breakpoints from the console by maybe monkey patching, or using this sweet command line API function, which I'll explain later. Okay. And the second part of the talk is I'm going to just talk a little bit about the debugging tips and tricks. I'll start out with high-level best practices, then go down into concrete tips that you can take home with you. Always be debugging. The ability to just run your code as often as possible will give you a huge leg up over the type of development where you hammer out code for hours just to discover that you made the wrong assumption about the library or API you're working with. Splitting up changes into incremental changes could validate your work as you go, in order not to invest too much in the wrong path. So think of it as a breadth first versus a depth first approach. Once you know that you can go back and run your program at any time, it just keeps the momentum going. A lot of my side projects die because they are left in a broken state. It's really hard to get motivated again when you go back to your project and you need to do all this refactoring just to get it to run again. Just seeing something on the screen will get the motivation going. So having the program in a runnable state allows you to take bold steps. You can take bets, you can go down paths where there is a small chance of success, but the returns could be huge. You can do it because you can always backtrack your steps. Also, being good with source control would help a lot with that. While in the debugger, change things, break things. It's your playground. Just do whatever you need to do to learn as much as possible, and then take all your learnings and dump them back into code. If you're like me and you have to go back and forth a million times just before running a piece of code that you've just written, because of all the small mistakes you do. A lot of the times I have typos, I use the wrong variable names, I call the wrong methods. With live edit, you can fix it in place. So you can sort of batch all your fixes and do it in one go. So to explain this more, you would write a piece of code, and that piece of code has a lot of typos and errors and mistakes. You would go into, for example, DevTools. You would run the code, and you would pause at every error, just fix it in place, just to get the code running, just to validate your idea, and then give whatever, all the mistakes that you made and dump them back into code. All the fixes. So we're still not all the way there, the tools I mean, but sometimes you can really implement full features without reloading the page. And I've done this before. I know there's been a lot of buzz recently about live coding, interactive programming, whatever you want to call it, because of the works of Brett Vector and Lighttable and things like that. And a lot of people are understandably skeptical about this. It may have been over-glorified, but I think there's at least some benefit to this type of programming. So this tip, I call it setting up traps. So as teams and as applications grow into teams do not grow into modules, but as teams grow and applications grow into many modules, and as the different interactions between the modules grow, it becomes really hard to know what part is touching what part and what code is changing what state. It's going to be hard to step debug all your code paths and be able to get all that information you need. It's almost impossible to keep the entire system in your head. We need a way to break on certain actions without needing to have explicit breakpoints. So the first trap that I'd like to share with you is breaking on methods. So traditionally, when you want to break on a method call, what you do is you go to the source, you set a breakpoint, and that's fine. But native methods do not have a source. So there's really no way to set a breakpoint on a native method. And you always need to know the source of the code that you're setting a breakpoint on. So it's really helpful to be able to monkey patch native classes just to be able to drop in a debugger statement. For example, imagine if a DOM element is not doing the default behavior, and you don't know why. You may suspect that something might be calling prevent default. So you may do something like override event.prototype.prevent default and drop in the debugger statement and then call the original function once again. And that way, when the debugger breaks, you can look up the call stack and see the offending code. Another trap you can set up is you can break on custom events. So DevTools give us a way to debug DOM events. For example, there's a command line API called monitor events. I'll talk a little bit about this later. But there's no way to do the same thing for JavaScript events. JavaScript events are not really part of the language spec. And everyone at least have one events library on the page. If you're using Backbone, you probably have two event systems on the page. You have the jQuery event system, and then you have the Backbone event system. If you're using Browserify, you have the Node event system. So sometimes you want to make sure that event is firing at the correct time. And other times you just want to pause and look at the arguments that's being passed in. You can do that by listening on an event and then dropping in a debugger statement. So whenever that event is fired, the debugger breaks and you can take a look at that. So another thing is breaking on property access. So WTF changes are basically changes that happens from under your feet. You don't know what part of the code base have changed what property on your have changed a property on your object. And a good way to break when that happens is to use getters and setters. In this example, I'm putting a setter on the value property on the counter object, and whenever that changes, the debugger would set a breakpoint, and then I'll look up the call stack and find the offending code. Breaking on callbacks. Similar to custom events, you have callbacks that runs when an async process has finished. You can also drop in a debugger statement with a callback just to get an idea when that async process has finished. Looking a little bit to the future, there's something called DOM mutation events. DOM mutation events allow you to listen to when the DOM mutates, for example, when a node is added, when a node is removed. So you can break on DOM mutation from DevTools by just right-clicking in the elements pane and setting break on DOM changes or whatever. But it doesn't give you fine-grained control over when to break and what kind of DOM mutations that you want to break on. For example, you can't break on DOM node additions. But with DOM mutation events, you can listen on exactly the event that you want to listen on, and you can break when that events happen, like we saw with the custom events. The problem with that is that DOM mutation events happen asynchronously, so you wouldn't get a call stack that points you to the offending code. However, this will change in Chrome Canary released async call stacks. It basically will give you an extended call stack and will show you the offended code that triggered that event. Similar to that, maybe we can break an object mutation. I'm saying maybe just because, so object mutation listeners are basically a new API called object.observe. It's also in Canary behind a flag. And what you can do is you can listen on different changes on objects, not just like setters and getters where you have to know the property name. You can listen on addition, deletion, on whatever you want on an object. And you can sort of break when something happened to that object. However, using the async call stack, you know, I was playing with it yesterday. I didn't seem to get a proper async call stack like I did with the DOM mutation events. But I'm assuming this is a bug and this will get fixed soon. So this is a little bit of something to look forward to in the future. I'm beginning to like the colors in this. All right. So I'm going to talk a little bit about the tools that we have at our disposal to help us with debugging. So first of all, the command line API has a lot of nice features. If you don't know what the command line API, basically whenever you're in the console, you can have some functions that you can use just in the command line. They're not in the global namespace. They're just available for you in the command line. And my favorites are a few of them. $0 will get you the current element that you have selected in the elements pane. $sign is basically an alias to the query selector role. Monitor events, and I think I've mentioned this before, but you can log every event that fires on an element when you call monitor events on an element. Get event listeners will get you an array of all the event listeners on an element. But for the exciting part, there are undocumented APIs that I discovered while trying to write a tool that does the exact same thing. And that sort of like proves my point towards, you know, the debugger is your playground. And I sort of found out about these, and they're not documented in the Chrome DevTools site. And they're amazing functions. What you can do with debug is, if you have a function reference, you can just pass it to debug, and it will set a breakpoint on the next time that function is called. It's amazing. And the other one is monitor, basically just like debug, but what it would do is it will log whenever that function is called. Debug utils is a tool I just written recently, which just does what I explained in terms of setting up traps. So it starts with $du, the functions, debug utils. DUV basically is will break the next time an event happens on an object. It will basically listen. it try to listen using whatever event system API you have. It will try add event listener, it will try on, it will try whatever is necessary to just try to add that trap to your object. DUG will do that for properties, DUS will do that for setting on properties, DUM will debug next time a method is called on an object. So check that out, it's on my GitHub, github.com, Masad, debug_utils. So I mentioned live edit before, and I found that live edit in Chrome is not as flexible as possible. The major problems is you can't have a build step to use when you're using live editing. So basically, if you're writing ES6 or writing CoffeeScript or writing ClojureScript, you can't really use the live edit feature. Using Chrome workspaces, you can map resources to the file system, but it doesn't really support remote file systems. The idea behind workspaces is that you can use DevTools as your primary sort of IDE to be able to do live editing. You have to also always work in Chrome DevTools, and you can get all the goodness from your favorite editor. So hopefully I described the problem correctly, but today I just open sourced a tool with Facebook called Flow. And with Flow, what you can do, you can live edit JavaScript, CSS, and even images. You can sit there in fucking Photoshop and be like changing your images, and it will automatically just live update in the browser without even reloading. It supports a build step and any configuration you have. It supports any development environment you have, and it's really easy to integrate, and it's made to be hackable. So a little bit about why I created Flow, which goes back to the problems that I mentioned. But when I joined Facebook last year, there's a lot of JavaScript goodness at Facebook. We use ES6, we use CommonJS, we use most of the really good things in the JavaScript community. If you want to learn more about how we use ES6, come tomorrow at the same time. Ben Newman will be giving a talk about how we're using ES6 at Facebook. But one of the problems that I was really facing was I was working on complex flows that is hidden behind like 3 clicks deep. And every time I changed something, and as I said, I'm a really sloppy typer, I would have to like reload the page, and that would take a long time, and then just click into the flow that I was changing, and just to change one letter in my code. So that drove me to try to solve the problem and try to create the most configurable tool for live editing. So how does Flow work? Flow basically is made up of a server and a client component. The server component is an NPM module. You require it, then you start it, and it will give you a server and a file system watcher. Whenever the file system changes, it will call a user-defined function that you define to map between file system, between files and between resources. If you've ever used Chrome workspaces, you sort of have to do this yourself, mapping between file system and resources. When I say resource, basically CSS, JavaScript, image, what have you. So after that, it will send it to the client. The client will update the code. It hooks into Chrome DevTools to get at the JavaScript live recompilation. So I think I have a little bit more time to sort of do a live demo. All right, so here I have a simple Browserify app. One part of the, so I have 2 modules, A.js and B.js. A.js is exporting a function that basically just console logs hello world. B.js, when it first is executed, it will log page loaded, and then it will require A, and then set an interval and keep calling A over and over again. What was that? Can't see it? What happened? Okay. What's the shortcut for mirroring? You don't know? All right, can you see it now? Oh, shit. All right. All right. You just kind of have to believe me. But you start flow from the console, and then if you go to the browser, let me try to invert. Maybe this is better? All right. So let me refresh. So what's going on here is that it's logging page loaded and then hello world. And then when I go back and change hello world to just hello yo, just recompose it on the fly and without reloading the page and just keeps on executing. You can do whatever you want here. Just add an alert for fun. Oh, I refreshed. I'm just like, I'm so used to refreshing that I just refreshed directly. All right. Hi, hello. All right, I'm just gonna do that for the next 30 minutes. I'm just kidding. All right, thank you. I'm done.